Okay. So we just got done with cosine. It's from 0 to pi. So 1 and quadrant 1 and 2. I think I was explaining this part, wasn't I? About this?
Yeah.
Yeah. You're not going to tell me 5 pi over 3, 7 pi over 4, and 11 pi over 6, because that's not behind the y-axis in that graph we were doing, because 5 pi over 3 is a positive x. So in order to tell me what 5 pi over 3 is, that would be negative 60 degrees, or negative pi over 3. Negative pi over 3 falls in this quadrant. And that's important to understand. We're going to do some example that has that in it. Okay, so let's talk about the arctangent. Same type of thing. If I said the arctangent of 1, kind of getting ahead of myself today, that would be pi over 4. Okay, versus you've been asked the tangent of pi over 4. What is the tangent of pi over 4? Tangent is y over x, isn't it? And at pi over 4 on your unit circle, that's 45 degrees. That coordinate is radical 2 over 2, radical 2 over 2. If I put y over x, isn't that something over itself? Which is 1. So the answer of tangent of pi over 4 is 1. I can use the arctangent, or the inverse of the tangent of 1, and that'll tell me it's pi over 4. Now your calculator won't do that. We are going to use calculator a little bit to do some things, because I'm going to be asking you things like this. What, that degree, how do I find the arctangent of that degree and the arcsine of that degree? And you don't know that stuff. Okay, but this is where we're getting to be able to use this. All right, so anyway, your domain of your tangent is all the reals. And what I would suggest you do, just for your own understanding, is get out your graphs of these inverses when you're looking at this, so it makes a little more sense for where this came from. We talked about it before, but it was the first time we ever discussed it. Anyway, it's the same. The range is the same as the sine, negative pi over 2 to pi over 2. Okay. All right. This right here is what's important. Really, the range for today is what's important. Having said that, example 4a. Now that you all understand this, I want the arcsine of negative radical 3 over 2. Now let me walk you through this as soon as you get caught up here. I lost about 7 minutes there. Where's that fire alarm? Looking at this and knowing what we said right here, I've given you the answer. Where did it come from? So here's how you ask this. Where is y equal to negative radical 3 over 2? So on my homework pages that I do, I sit here and I actually draw a circle and I say, okay, well, the square root of 3 over 2 is a long leg, but y is negative. So y is negative, that's down here. Here's y. Y is negative in the 4th and the 3rd quadrants. Correct? So if I go down to negative radical 3 over 2, then I'm going to get 2 answers for what I'm looking for. Except, I'm not really looking for both of these, right? All right, so if this is the angle, let's actually go back here a little bit. Didn't draw quite right. These are right triangles. Okay, this is my long leg, that's negative radical 3 over 2. This is my long leg, it's negative radical 3 over 2. Alright, so this is a minus 60 degrees, these are both 60-degree reference angles. But I'm not interested in both of these. I'm only interested because I'm talking about the inverse. If I was talking about the sine of these two, you'd give me both of these. But I'm asking the inverse, and the inverse is bound by this range between negative pi over 2 and pi over 2. So anything in the 2nd and the 3rd quadrants, we don't care about. It doesn't work. So I'm not going to worry about this right here. So that's what you got to watch. You got to watch for those things. So I'm only interested in this one right here. What was that radian measure on your unit circle? You had 3 blanks there. what was the first one? This was this was 3 pi over 2. This one was 5 pi over 3. That was that blank, except this is a positive 5 pi over 3. So I want the coterminal angle that goes the other way because I want it in the negative part. So what is this angle right here going this direction? What's the degree? Negative 60 degrees. So what is negative 60 degrees in radian measure? Negative pi over 3. So the answer is negative pi over 3. 5 pi over 3 is your coterminal angle going in the positive direction. Okay? Let's do some more. So I got 5 more that do the same thing. Alright? I think you'll catch on. So part B, we're going to do the cosine and the tangent. So the arc cosine of negative radical 2 over 2. 1. Where is x negative? And we're only dealing with 0 to pi. So where is x negative? Quadrant 2. What do you know about radical 2 over 2? What kind of angle is that?
45.
It's a 45 degree angle. So we know that that's it right there. Now the question is, what is, on your unit circle, what was that position? Everybody watch how easy the 45s are. I want everybody to watch. If you're good with your unit circle, then you don't need to worry about this. But on a unit circle, my 45s are the easiest ones to figure out. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 1, 3, 5, 7. Those are the easiest ones to figure out on your unit circle. So, that's my answer. The arc cosine of negative radical 2 over 2 is 3 pi over 4. Now these are all going to be positive for your inverse cosine, because you're going in the positive area for your radian measure. Alright, what about tangent? This is part C. The arc tangent, which one are we going to do? Arc tangent of negative radical 3. Now this is more difficult, because you say, wait a minute, I don't know what the square root of 3 is, because I only have to deal with these on my unit circle. These are the only numbers that are on my unit circle. So how do I get radical 3? Well, what is tangent in terms of x and y? Y over x. So that means I'm putting one of these over another one. If I take radical 3 over 2 over 1/2, what does that give me? Top times the reciprocal of this gives me radical 3. That's how you do it. So the y is radical 3 over 2 and the x is 1/2. Now, so right now, that's just showing you where the radical 3 came from. Tangent has to be between negative radical 2, negative pi over 2 to pi over 2. Is tangent positive or negative? Negative. So am I in the first quadrant, second, or fourth quadrant? Fourth quadrant. The y is negative, the x is positive. So, long leg, short leg. The short leg is 1/2. The long leg is negative radical 3 over 2. What is that radian measure?
Negative pi over 3.
Excellent. Negative pi over 3. So yes, guys, it takes just a little bit of time to think through the process. Think how many questions I asked you just on this. I asked you what tangent was in terms of x and y. I asked you how you get radical 3. This is the toughest one because you have to realize you're putting a fraction over another fraction. So you just have to fiddle with it till you get what they have when you're dealing with tangent. Sine and cosine are the easier ones. Okay? Alright, there's the first 3 problems you're starting to get into. Let's do 3 more problems that are kind of like this. So this is going to be example 6, A, B, and C. quick way. Man, it's hot here. I'm gonna give you some simpler ones. Maybe this will help you. Okay. The arc sine of -1. First, let me ask you, where are we at? Which quadrants are we going to use? Which quadrants are we going to use?
First and one.
First and fourth one. Okay, so we'll just use this one. Where is the sign negative? Because sine is y. So we're going to be in quadrant 4. That's just to understand where we're at. Now, where is y -1? At -5/2, right? Done. Okay, now you guys do this one. Having done this. The arc cosine of +1. You guys do that. The arc cosine of +1.
Just went out of focus. When? Just now. Like it's been fine.